So let me quickly tell you the topics that I will be covering in this session. First, I will tell you what is software testing and what is the need for software testing. Next, I will talk about software development lifecycle and its various models. After that, I will walk you through principles of testing. And once you understand these fundamentals, next, let's dive into software testing lifecycle and understand various steps involved in it. And moving further to the discussion, you will be seeing methods of testing, its levels, and some artifacts of software testing documentation. And I will also talk about defect management and bug lifecycle. Now, moving to automation testing, you will be understanding fundamentals of automation testing and its various tools. You will also be learning why Selenium is most preferable tool for automation testing. And finally, I will wrap up this session by telling you how to locate elements and perform actions on the web page using Selenium. Without any further ado, let's get straight into the module. First, let's understand what is software testing. Software testing can be defined as an activity to check whether the actual results match the expected results. And it also ensures that the product is free from any bug or defect. Testing of a software also involves the implementation of product's module or system part for evaluating all or some of its properties. Through testing, testers can identify errors, gaps in requirement, or missing elements in a project or a system. Testing can be done both by manually or with the help of automated tools available in the market. So why testing is important? Software testing is where it all boils down to. Today's world of technology is completely dominated by machines, and their behavior is controlled by the software powering it. Will the machines behave exactly as we want them to? Every time, everywhere? Yes. The answer to all these questions lie in software testing. By the end of the day, it is software application success rate which is going to control your business growth. The same thing can be said even for web applications because most businesses today are completely reliant on the internet. For example, you can see here the airplane crash and the bankrupt. Why it is happening? Just because the system was not tested properly before it was launched. And that's why we say testing is important. Else, it might lead to a loss of monetary value, jobs, or even loss of a human. And these are the examples of untested software that becomes hazardous. So software testing plays a significant role in testing a software or a system. If the bugs or a defect is not properly removed from the system, it might lead to system failure. And that's why testing is important. Now, let's see who performs software testing. This question's answer is depending on the process and its connected project stakeholders. In the industry of information technology, big companies have team members who bear the responsibility for evaluating the project or software based on the requirements during the test phase. Moreover, some bugs can get detected if proper testing is done in the development of a software or application. So, people who can do testing are software testers, project developer, project lead, team manager, and end users. So, these are the people who takes care of software testing. Having understood this, let's see what is software development life cycle. Software development life cycle is a process used by the software industry to design, develop, and test high-quality softwares. SDLC, that is Software Development Life Cycle, aims to produce a high-quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. As you can see here, it involves many phases, and let me explain you each of these phases. First, requirement phase. Requirement gathering and analysis is the most important phase in SDLC. Here, business analyst collects the requirement from the customer or client as per the client's business needs and documents the requirements in the business requirement specification. That is the document name, and it varies depending upon the organization. Some examples are CRS, that is Customer Requirement Specification, and some might call it as business specification as well. And then they provide the same to the development team. Next, analysis phase. Once the requirement gathering and analysis is done, the next step is to define and document the product requirements and get them approved by the customer. This is done through SRS, that is Software Requirement Specification Document. And software requirement specification consists of all the product requirement to be designed and developed during the project lifecycle. And key people involved in this phase are project manager, business analyst, and senior members of the team. And the outcome of this phase will be software requirement specification. Now, moving to design phase, it has two steps. One, high level design, and the other one, low level design. So in high level design, it gives the architecture of the software product to be developed and is done by the architects and senior developers. In low level design, it is done by senior developers. Here, it describes how each and every feature in the product should work and how every component should work. Here, only the design will be there and not the code. And the outcome from this phase is the high level document and low level document, which works as an input to the next phase. So next is the development or your coding phase. So what happens here? Developers of all levels, that is seniors, juniors, freshers, all are involved in this phase. This is the phase where we start building the software and start writing the code for the product. The outcome from this phase is the source code document and the developed product. Now talking about the testing phase, here when the software is ready, it is sent to the testing document where test team tests it thoroughly for different defects. They either test the software manually or using the automated tools depending on the process defined in software testing lifecycle, and also ensures that each and every component of the software works fine. Once the QA, that is the quality analyst, makes sure that the software is error-free, it goes to the next stage, which is implementation. And the outcome of this phase is the quality product and the testing artifacts. I'll talk about the testing artifacts at a later part. So once all this is done, the next and the last step is deployment and maintenance phase. After successful testing, the product is delivered and deployed to the customer for the use. Deployment is done by the deployment engineers or the implementation engineers. Once when the customers start using the developed system, then the actual problems will come up and needs to be solved from time to time. Fixing the issues found by the customer comes in maintenance phase. 100% testing is not possible because the way testers test the product is different from the way customer use the product. Maintenance should be done as per SLA, that is service level agreement. These are the various phases involved in software development lifecycle, and this is how it works. Now we have different models of software development lifecycle like waterfall model, spiral model, agile model, etc. Now let's talk about waterfall model and understand how it works. Waterfall model is a traditional model. It is a sequential design process that is often used in SDLC, in which the progress is seen as flowing downwards like a waterfall through the different phases such as requirement gathering, feasibility study, analysis, design, coding, testing, installation, and maintenance. Every next phase is begun only once the goal of the previous phase is completed. This methodology is preferred in projects where quality is more important as compared to schedule or cost. The methodology is best suitable for short-term projects where the requirements will not change, for example, your attendance management or calculator, etc. So benefits of using this model are requirements do not change nor does the design and code. So we get a stable product. And this model is very simple to implement. Requirements are finalized earlier in the life cycle, so there won't be any chaos in the next phases. And requirement resources to implement this model are minimal compared to other methodologies. And every phase has specific deliverables. It gives high visibility to the project manager and clients about the progress of the project. So what are its disadvantages? The main disadvantage is that backtracking is not possible. That is, we cannot go back and change the requirements once the design stage is reached. And change in requirements leads to change in design and code, which results defect in the project due to overlapping of phases. And by this, customer may not be satisfied if the changes that they need are not incorporated in the product. And the end of the waterfall model may not be a flexible product. And this model can be used only when the requirements are very well known and fixed. And it is also not suitable for long-term projects where requirements may change time to time. So this is about waterfall model. Next, let's take a look at Bohem spiral model. Spiral model works in an iterative nature. It is a combination of both prototype development process and linear development process, that is your waterfall model. And this model places more emphasis on risk analysis. Mostly this model adopts to large and complicated projects where risk is very high. Every iteration starts with a planning and ends with the product evaluation by client. So let's take an example of the product development team like Microsoft. They know that there will be a high risk and they face lots of difficulties in the journey of developing and releasing the project. And also they know that they will release next version of product when the current version is in existence. And they prefer spiral model to develop the product in an iterative nature. So they could release one version of the product to the end user and start developing next version which includes new enhancements and improvements on the previous version. And that is based on the issues faced by the user in the previous version. Like Microsoft released Windows 8 and improved it based on user feedback and released the next version, that is 8.1, and it went on. So it mainly undergoes 4 phases, that is planning phase, and in this phase requirement gathering, cost estimation and resource allocation is being done. And next phase is risk analysis phase. Here strengths and weaknesses of the project is being known. And next comes your design on engineering phase where coding, internal testing and deployment is being done. And the last is the evaluation phase like client evaluation, client side testing to get the feedback, etc. So benefits of using this model are it allows requirement changes and it is also suitable for large and complicated projects. The main thing is it allows better risk analysis and is cost effective due to good risk management. And disadvantages is that it is not suitable for small projects and the success of a project depends on the risk analysis phase. That's all. So this is all about the spiral model and different types of models in SDLC. Now let's move further and understand principles of testing. Testing of software is exceptionally imaginative and an intellectual task for testers to perform. Testing of software or applications pursue some principles that are mentioned over here. These principles also play a significant role for software tester to test the project, and they are: first one, software testing can help in detecting bugs. Testing any software or project can help in revealing few or some defects that may or may not be detected by developers. However, testing of software alone cannot confirm that your developed product or software is error-free. Hence, it's essential to devise test cases and find out as many defects as possible. Next, testing with effectiveness is impossible. So what is this? Until your project or application under test has a straightforward structure having limited input, it won't be likely or achievable to check and test all feasible sets of data, modules, and scenarios. And next, early testing. The earlier you will begin to test your project or software, the better you will find to utilize your existing time. Next, defect in clustering. At the time of testing, you can observe that majority of the defects or bugs that are reported are because of a small number of modules inside your software or system. Next, software testing is context dependent and error-free or bug-free software is a myth. Just because when a tester tested an application and did not detect any defects in the project doesn't indicate or imply that your software is ready for shipping. So, at the time of testing modules or working of software, you as a tester needs to test whether your software is meeting all the requirements of the client or not and whether the bugs found during testing has been mended or not. These many factors need to be considered before shipping the software or releasing it to the market. So these are some of the principles of software testing that one should keep in mind while testing a software. Now let's move further and understand one of the most widely used model, that is verification and validation model. To understand this model, let's first understand what is verification and validation in software. First, verification. Verification is a static analysis technique. In this technique, testing is done without executing the code. For example, you can say inspection, walkthrough, reviews, etc. Next, validation. Validation is a dynamic analysis technique where testing is done by executing the code. For example, your functional and non-functional testing techniques. In verification and validation model, the development and QA activities are done simultaneously. There is no discrete phase called testing. Rather, testing starts right from the requirement phase. The verification and validation activities go hand in hand. So just have a look at the figure over here. And you can see here in a typical development process, the left hand side shows the development activities and the right hand side shows the testing activities. I should not be wrong if I say that in the development phase, both verification and validation are performed along with the actual development activities. Now let's understand each of these phases in depth. So first talking about the left hand side, as you all know, left hand side activities are the development activities. Normally we feel what testing can we do in the development phase? But this is the beauty of the model which demonstrates that testing can be done in all phases of development activities as well. So here requirements are collected, analyzed and studied. Here how the system is implemented is not important, but what the system is supposed to do is important. Like brainstorming sessions, walkthroughs, interviews are all done here to have the objective set clear. So verification activities like requirement reviews and validation activities like creation of user acceptance test and its test cases, and the artifacts produced here will be requirement understanding document and user acceptance test cases, that is UAT test cases. So this is about the requirement analysis phase. Now talking about software specification, in this phase a high level design of the software is built. The team studies and investigates on how the requirements could be implemented, and the technical feasibility of the requirements is also studied. And here the team also comes up with the modules that would be created based on the software and hardware needs. So verification activities that include here are design reviews and validation activities like creation of system test plan and cases and creation of traceability metrics. And the artifacts produced here are system test cases, feasibility reports, system test plan, hardware software requirements and modules to be created. So the next phase is the architectural design or your high level design. In this phase, based on the high level design, software architecture is created. The modules, their relationship and dependencies, architectural diagrams, database tables, technology details are all finalized in this phase. So again, verification activities like design reviews are included and validation activities like integration test plan and test cases, and the artifacts produced are design documents, integration test plan and test cases, and database table designs, etc. Now coming to module design, also called as low level design. In this phase, each and every module of the software component are designed individually. Methods, classes, interfaces, data types, etc. are all finalized in this phase. So again, verification activities like design reviews is included and validation activities like creation and review of unit test cases, and the artifacts that are produced will be unit test cases. So next we have the implementation or code. In this phase, actual coding is done. So code review and test cases review are verification activities, and creation of functional test cases are validation activities, and artifacts produced will be test cases and review checklist. So this is all about left hand side, that is your development phase. Now talking about the right hand side, this side demonstrates the testing activities or validation phase. So we will start from bottom, that is your unit testing. In this phase, all the unit test cases created in the low level design are executed. So what is unit testing? Unit testing is a white box testing technique where a piece of code is written which invokes a method to test whether the code snippet is giving the expected output or not. This testing is basically performed by the development team. In case of any anomaly, defects are logged and tracked. So artifacts produced here are unit test execution results. Next comes integration testing. In this phase, the integration test cases are executed which were created in the architectural design or your high level design phase. In case of any anomalies, Defects are logged and tracked even here. So now talking about integration testing. In this phase, the integration test cases are executed which were created in the architectural design or your high-level design phase. In case of any anomalies, defects are logged and tracked. So in integration testing, it validates whether the components of the application works together as expected. And the artifacts produced here are integration test results. And now coming to system testing, in this phase, all the system test cases, functional test cases, and non-functional test cases are executed. In other words, the actual and full-fledged testing of the application takes place here. So defects are logged and tracked for its closure. Progress reporting is also a major part in this phase. The traceability metrics are updated to check the coverage and risk mitigated. And the artifacts produced are test results, test logs, defect report, test summary report, and updated traceability matrices. And now talking about the last phase, that is user acceptance testing. So acceptance testing is basically related to business requirements testing. Here, testing is done to validate that the business requirements are met in the user environment. And compatibility testing and sometimes non-functional testing are also done in this phase. And the artifacts produced will be user acceptance test results, updated business coverage matrices. So these are the various phases involved in the testing, that is the right hand side of the model. That's why it is called V and V model, where verification is nothing but development phase and validation is testing phase. So when to use V model? V model is to be used when requirement is well defined and not ambiguous, acceptance criteria are well defined, project is short to medium in size, and technology and tools used are not dynamic. These are the situations when you should use verification and validation model. Now let's move further and understand software testing life cycle. Software testing life cycle is a testing process which is executed in systematic and planned manner. In software testing life cycle process, different activities are carried out to improve the quality of the product. So these are the various stages involved in software testing life cycle. First, requirement analysis. This is the very first step in software testing life cycle. In this step, the quality assurance team, that is your QA team, understands the requirement in terms of what we will be testing and figure out the testable requirements. If any conflict, missing or not understood any requirement, then QA teams follows up with the various stakeholders like business analyst, system architecture, client, technical manager to better understand the detailed knowledge of requirement. And after that we have test planning. Test planning is most important phase of software testing life cycle where all testing strategy is defined. This phase is also called as test strategy phase. In this phase, typically test manager is involved to determine the effort and cost estimates for the entire project. This phase will be kicked off when the requirement gathering phase is completed, and based on the requirement analysis we can start preparing the test plan. And the result of test planning phase will be the test plan or test strategy or testing effort estimation documents. Once test planning phase is completed, then QA team can start with test cases development activity. So next we have test case development, and this is started once the test planning activity is finished. This is the phase where testing team write down the detailed test cases. Along with test cases, testing team also prepares the test data for testing. Once the test cases are ready, then these test cases can be reviewed by peer members or QA lead. And also the requirement traceability matrix is prepared. So what is this? Requirement traceability matrix is an industry accepted format for tracking requirements where each test case is mapped with the requirement. And using this, RTM, that is requirement traceability matrix, can track backward and forward traceability. After all this, you have to set up the environment for testing. So this is a vital part of STLC, and basically test environment decides on which condition software is tested, and it is an independent activity and can be started parallel with test case development. Next we have test execution. Once the preparation of test case development and test environment setup is completed, then test execution phase can be kicked off. In this phase, Testing teams start executing test cases based on prepared test planning and prepared test cases in the prior step. And finally, we have the test cycle closure. So in this, once the test case is passed, then same can be marked as passed. If any test case is failed, then corresponding defect can be reported to development team via bug tracking system, and bug can be linked for corresponding test cases for further analysis. So these are the various phases involved in software testing life cycle. Before I go further, let me clear out software testing is of two types: manual testing and automation testing. And Selenium was founded as an automation testing tool to overcome the limitations and drawbacks of manual testing. So till now, whatever you learned was manual testing. That is, the testing of a software is done manually without the use of automated tool or applications that are available in the market. Automation testing is an automated technique where the tester writes scripts by own and uses suitable tool to test the software. It is basically an automation process of a manual process. Like regression testing, automation testing is also used to test the application from load, performance, and stress point of view. What are the challenges faced by manual testing? Manual testing means the application is tested manually by QA testers, and tests needs to be performed manually in every environment using a different data set, and success failure rate of every transaction should be recorded. So look at the image over here. You can see a poor chap over here who manually verifies the transactions recorded. The challenges he is facing cause fatigue, boredom, delay in work, mistake and errors because of manual effort. And this leads to the need for automation testing. And automation testing beats manual testing every time. Why? Because it is faster, needs less investment in human resource, it is not prone to errors, frequent execution of tests is possible, support lights out execution, and also supports regression and functional testing as well. And let's take a similar example. Suppose there is a login page and we have to verify if all the login attempts are successful. Then it will be really very easy to write a piece of code which will validate if all transaction or login attempts are success or not. Moreover, these tests can be configured in such a way that they are tested in different environments and web browsers. What else can be done? You can automate the generation of result file by scheduling it for a particular time during the day. Then you can also automate the generation of reports based on those results. And the key point is that automation testing makes a tester's job a whole lot simpler. So these are some of the challenges faced with manual testing, and automation testing overcomes it. Now let's see different testing methods of software. First is black box testing. This testing is also called as a behavioral testing, where the software tests the internal structure, design and implementation, and the user interface of the product that is being tested is not already known to the tester. So that is the reason it is called as black box, where the input is being passed as a test case to the black box, but the internal implementation details are not known to the tester and the output is being given. Next, white box testing. This type of technique deals with testing the internal structure, logic design, and implementation of different modules. This is also called as a glass box testing, where the internal implementation details are known to the tester. That is the code logic, internal logic design, and many more. And next we have gray box testing. In this, it combines a concept of both black box and white box. That is, internal implementation details are partly known to the tester, while the rest of the internal implementation details are not known to the tester. And that's the reason it is called as gray box testing. So these are the three methods of software testing. Now let's see the difference between functional and non-functional testing. As already listed, functional testing is performed before non-functional testing, and non-functional testing is performed after functional testing. And functional testing is based on customer requirements. On the other hand, non-functional is based on customers' expectations. Functional testing describes what the product does, and non-functional describes how the product works. And examples of functional testing are unit testing, acceptance, smoke testing, integration, and regression testing. And non-functional testing includes performance testing, volume testing, scalability, load testing, strain and stress testing, etc. So these are the differences between functional and non-functional testing. Now let's talk about software testing levels. It starts from unit testing, where unit test cases are produced, and then it goes to integration testing, where the software is combined and tested and it produces integration test cases. And then comes system testing, where the integrated software or project is tested. And then comes acceptance testing, where the system needs to be tested for adequacy. So these are the software testing levels that starts off with unit testing and ends with acceptance testing. Now let's move further and understand software testing documentation. Documenting the test case deals with documentation part of the developed product, which should have to be prepared before or at the time of software testing. Documenting the test cases will facilitate you to estimate the testing effort you will need along with the test coverage and tracking and tracing requirement. Here you will learn to dig into how documentation is beneficial while testing along with some other features of it. So why do you think documentation is necessary? Some commonly applied documentation artifacts associated with software testing are test plan, test scenario, test case, and traceability matrix. Let's discuss each of these in brief. First, test plan. Test plan provides the outline strategy which will be implemented for testing the application, and the resources which will be needed are also described. It also holds the details about on which environment the test will be performed. So let's take an example of how you have to maintain a test plan report. So this is my test plan report, where I have columns like test number, the type of the test, target file, test name, purpose of the test, test situation, expected output, actual output, and outcomes and actions that are required. For example, say you are testing a website. So the test type will be website and you have to give your test number. Say you are testing on particular login information, you can give the target file as login information, and you can give whatever the test that you're performing, say for example unit testing, and you can check the purpose and the situations, whether all the clicks are working or not, or the email address is being entered or not in the login page, and whatever the output that you expect and whatever the actual output that arrives, and what is the outcome of it, and the actions that you need to be performed. These are all the main considerations of a test plan report. Now let's see what is a test scenario. Test scenario can be considered as a single line statement which notifies the area in which your application will experiment. This artifact is needed for ensuring the overall procedure tested from start to finish. So again, this is your test scenario, where you need to have your use case ID, your requirement ID, the scenario on which you're working on, and what is the test scenario and how many test cases, that is the number of test cases that is required. So you can go on documenting all the records over here in the test scenario. Next is test case. Test cases engage in collected step and conditions with inputs which can be implemented at the time of testing. This activity focuses on making sure whether a product went through a set of tests or fails by any means, such as functionality or other aspects. Many types of test cases are being checked during testing, like functional test cases, negative error test cases, logical and physical test cases, and user interface test cases as well. So these are the columns which are necessary for a test case. That is your test case ID, your test case, whatever it is, its description, the step that you take for testing a particular software or a particular test case, and its description, again your expected result, actual output, status, and comment. Now the last artifact that we have is traceability matrix. It is also known as requirement traceability matrix, and it contains a table which sketches the requirements when your product's software development lifecycle is being created. This documenting artifact can be implemented for forward tracing, which is to go from designing, or can be implemented for backward tracing as well, which is the reverse of forward tracing. So this is how you put a traceability matrix. That is, you will be having your requirement traceability where you have n number of test cases, and here you have business requirements. So the matrix will be put if the result will be passed on both the ends. So this is all about the documentation artifacts and the various types of artifacts that are involved in software documentation. Now let's talk about defect management. As we know, defect management is a part of software testing process. But what exactly is defect management in software testing is not being known. Now I will talk about it and tell you what exactly is defect management process. To realize what defect management process actually is, we should first understand the definition. Generally, defect management can be defined as a process of detecting bugs and fixing them. It is necessary to say that bugs occur constantly in the process of software development. They are a part of the software industry, and that is because of the fact that software development is quite a complex process. The team members are usually placed in strict time frames. They must write large pieces of code every day, and they usually don't have time to think about how to avoid bugs. Hence, every software development project requires a process that helps to detect defects and fix them. The process of defect management or bug tracking is usually conducted at the stage of product testing. Without realizing this, it would be hard to understand the nature of defect management. Software testing can be conducted in two different ways. Usually, the developers test their product themselves. However, there's also a type of testing that is based on user involvement. The final users are often provided with an ability to report on the bugs they find. Nevertheless, but this is not the best way of testing because the users could hardly find all the bugs. And there are four steps involved in defect management process, and they are as shown on the screen. The first step is the stage of defect detecting. We already mentioned that it can be conducted either by the team of developers or by the users. Regardless of the type of the testing, the main goal is to detect all the bugs in the final product or its part. Next step is formulation of bug reports. So these are the documents that include all necessary information about certain bugs. Usually, they contain data on the type of bug and the possible way of its correction. And next step, that is the third step, is the stage of bug fixing. After the bugs are fixed, they should be tested once more to make sure that the software works properly. And during the final step, the bug list is created. So this is a document that contains information about all the bugs that occurred during the project's performance. And the team often uses the bug list because the similar bugs have occurred. So this is all about the defect management process. Next, we'll see what is a defect life cycle or a bug life cycle. Defect life cycle is a cycle which a defect or a bug goes through during its lifetime. It starts when a defect is found and ends when a defect is closed after ensuring it's not reproduced. Defect life cycle is related to the bug found during testing. This life cycle can vary from organization to organization and also from project to project based on several factors like organization policy, software development model like agile, iterative, project timeline, team structure, etc. Bug or defect life cycle consists of these following stages, and that starts from new. This is the stage when a defect is logged and posted for the first time, and that defect state is given as new. Next, assign. After the tester has posted the bug, the lead of the tester approves that the bug is genuine and he assigns the bug to corresponding developer and the developer team, and this state is given as assigned. Next, active or open. At this state, the developer has started analyzing and working on the defect fix. And when developer makes necessary code changes and verifies the changes, he or she can make the bug status as fixed and the bug is passed to the testing team. So at this stage, the tester do the testing of the changed code which the developer has given to him to check whether the defect has got fixed or not. And as you can see on the left hand side, you have a reopen state. In this, if the bug still exists even after the bug is fixed by the developer, the tester changes the status to reopened. Again, the bug goes through the life cycle once again. And next, again it will go through verified. That is, it should be verified by the tester again and again to check whether the bug is completely removed and the software or a particular product is error free. And then you have a close state. That means once the bug is fixed, it is tested by the tester. If the tester feels that the bug no longer exists in the software, he or she changes the status of the bug to closed. This state means that the bug is fixed, tested, and approved. And you can see from active state, it goes to two more stages, that is rejected and deferred. Rejected means if the developer feels that the bug is not genuine, he rejects the bug. Then the state of the bug is changed to rejected. Deferred state indicates the bug is expected to be fixed in next releases. The reasons for changing the bug to this state have many factors. Some of them are priority of the bug may be low, lack of time for the release, or the bug may not have major effect on the software. And that's the reason it is said as deferred. So this is all about the bug life cycle and the various stages the bug goes through once it is new till closed. Now let's move on to the widely used software testing type, that is automation testing. As I have already mentioned, automation testing is an automated technique where the tester writes scripts by own and uses suitable tools to test the software. It is basically an automation process of a manual process. So there are many tools to carry out automation testing like Selenium, TestingViz, HPE Unified Functional Testing, TestCompete, Ranorax, WaitIR, WaitIN, Telerik Test Studio, Tosca Test, and many more. So what is Selenium and why it is a preferable tool? Selenium is an open source tool which is used for automating the tests carried on the web browser. Wait, before you get carried away, let me reiterate it. Only testing of web applications is possible with Selenium. We can neither test any desktop application nor test any mobile application using Selenium. Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. So why do you prefer Selenium? The reasons behind ever-growing popularity of Selenium are test scripts can be written in any of these programming languages like Java, Python, C#, PHP, Ruby, Perl, and .NET as well. And tests can also be carried out in any of the OS like Windows operating system, Mac, or Linux. Not only that, it can be carried out using any browser like Mozilla, Internet Explorer, Google Chrome, Opera, Safari, etc. And tests can be integrated with tools like TestNG and JUnit for managing test cases and generating the reports. And it can also be integrated with Maven, Jenkins, and Docker to achieve continuous testing. And that is the reason everyone prefers Selenium over other automation testing tools. So how to locate web elements and perform action? So this is nothing but your web page where you have inspected the element and you're trying to locate a particular element on the web page. So how is that done? I'll tell you how. That is with the help of Selenium locators. So what is a locator? Locator can be termed as an address that identifies a web element uniquely within the web page. They are the HTML properties of the web element which tells Selenium about the web element it needs to perform the action on. Selenium uses locators to interact with the web element on the web page. They are considered as the lifeblood of the tests. Using the right locator ensures that the tests are faster, more reliable, or has lower maintenance over releases. If you are fortunate enough to be working with unique IDs and classes, then you are usually all set. But there will be times when choosing a right locator will become a nightmare. It can be a real challenge to verify that you have the right locators to accomplish whatever you want. So there are diverse range of web elements like text box, ID, radio button, etc. And identifying these can be a tricky approach. So let's see how and what are the different types of locators that can be used to locate a particular web element on the web page. So we have ID, name, link text, CSS selector, partial link text, and XPath. First, coming to ID, the best and most popular method to identify web element is to use ID. The ID of each element is alleged to be unique. IDs are the safest and fastest locator option and always should be the first choice even when there are multiple choices. It's like an employee number or account which will be unique. Let's see an example how to locate it and how to write a particular script for Selenium. So the very first step is to open your Eclipse, create a class. I have created a class called first Selenium script and I have written my main method. Now next what I will do. So the first step is to register Chrome driver. Why? When you write a script and run it, the Chrome driver will launch the Google Chrome if you are using Google Chrome web browser, or if you are using Mozilla Firefox, you can choose Keycode driver. So as I'm using Chrome driver, I have to set the properties for Chrome driver. I'll set it like this. I'll give system.setProperty. Okay. Now I have launched my Chrome driver. So what's next? Now I will use driver.get method to navigate through ebay.com. Why? Because I'm using ebay.com website to test it. So I'll copy this and here I'll give driver.get and I will paste the value of eBay within double quotes. Okay. After I do this, I have to use the ID locator to locate a particular web element. Now suppose say I want to locate the search box. What I will do? I'll right click on this, choose inspect. As I click on this thing, you can see the search box is getting highlighted, which implies as I mouse over on this, you can see this search for anything was getting highlighted. As you can see here, it has a ID attribute whose value is GHAC. Okay. So I'll copy this and I'll write one method here, that is driver.findElement by.id. And what is the value of ID that you copied from eBay? It is GHAC. Okay. So when you try to locate this by ID, that particular search box will be highlighted. Okay, now I want to do something like, say, I want to enter some values for this. So how will I do that? I want to give like something called guitar or say mobile and click on the search. When I search it over here, you can see the search filtered by shop by brand. Okay. So what I'm doing here is I'm creating it manually. So if I want to search the same thing by Selenium, how will I do that? For that, what I'll use, after this, I will use a method called sendKeys. Okay. And I will pass the value of sendKeys as mobile. So now, next, once you give the sendKeys as mobiles, it will enter the value over here like mobiles. Okay. But it won't give a search. So in order to get the search, what we should do? You can see there's a search button over here. So inspect that. And again, even that has a ID whose value is GH button. Okay. So what I'll do, I'll just copy this. Again, I'll write driver.findElement by ID and send it as GH button. As it is a button, I have to use a click method because we are clicking on the button and not sending any values to the button. But if it is a text box, then you can send the keys and send the value. Okay, simple. Save it. Now what's the next step? You are giving ID and searching mobiles and clicking on the search box. Right. But there is something called implicit waits that is required to wait for a particular amount of time and then proceed further. So I will be writing some methods over here. So I will use this method. Why? Because I want to maximize the window of the output and I want to delete all the cookies and I want to set the page timer for 40 seconds. It's throwing an exception because I haven't imported the package. And one more thing, I have set the implicitly wait for 30 seconds, which implies it will wait for 30 seconds unless and until the element is loaded, that is this one. So even after 30 seconds, if the element is not loaded, then it will throw an exception saying no such element found. Okay. So that is the reason I'm using implicit wait. But if the element is loaded within first 2 or 5 seconds, then the rest of 25 seconds will be ignored. That is the reason implicit and explicit waits both are called as dynamic waits. I'll explain you explicit wait also. Don't worry. For now, Let's run the program and check the output. As you can see, Chrome driver launched Google Chrome, maximized the window, and opened ebay.com. You can see it entered mobiles by itself, loaded, and gave the output as desired. Correct? Sounds much interesting, right? Everything is an automated. Correct? Yep, that's true. Now let's learn one more locator, that is name. Simple, instead of ID, we have to use name. That's all. It's same like ID only, but we have to use name. To locate a particular element using name locator, I'll be using Myntra.com. Say I want to do sign up, and you can see here it has the email address tab. I'll just click on inspect, and you can see it has an element whose value is email. Name is an attribute whose value is email. Correct? So let's see how to do that. I want to sign up. I'll inspect on this. You can see it has a name whose value is email. So I'll copy this, and instead of by ID, I will make it as by name. So here by is a class, and name will be your locator or your web element or your locator, and I will paste the value, that is email. And I want to send email like something edureka@gmail.com, my email address. And next, I can also write the password as well. Even that has a name attribute whose value is password. So again, by name, I'll give, and I'll change this as password. And I will send something like, depending on my choice. Sorry, it's capital K. Now say, once I enter the email, I want it to wait for 2 to 3 seconds and then enter the password. In that case, what I'll do, after the statement, I'll give thread.sleep of 3000, which implies it will take 3 seconds only. Okay, so save this and run the program. So again, Chrome driver launched Google Chrome, navigated through Myntra.com to this page, and it entered edureka@gmail.com, waiting for 3 seconds and then entered the password. Correct? As you can see, it is written as Chrome is being controlled by automated test software. Correct? So this is how you can use thread.sleep in between the two elements and go on. Next, we have link text, that is useful only for links. That starts with the anchor tag and hrefs, and if something text is present in the link, then you can use this link text locator. And next you have CSS selector. It's very easy. So CSS is mainly used to provide style rules for the web pages, and we can use for identifying one or more elements in the web page using CSS. If you start using CSS selectors to identify elements, you will love the speed. So I'll show you one small example how to use CSS selectors. So to demonstrate CSS selector, say I want to locate the search box using CSS selector. So I have inspected that, and I have mentioned ID is a unique locator. So whenever you write anything, it will be with respect to ID. So I'll show you how to locate the element using CSS. Click on elements and click Ctrl F, where you can write string, selector, or XPath. And remember, CSS selector always starts with hash. And what is the value of ID? It is GHAC. Correct? So I'll just give GHAC. On writing that, you can see it highlighted the element, which implies it was able to locate the particular element using CSS selector. Sounds much easier, right? Instead of finding the name, your link text, everything, just write the ID value and you will be able to locate the particular element. Correct? Same thing, you can copy this and paste it over here. I'm sorry, I have to again change it to ebay.com first. I'm sorry. Here I'll make it as by CSS selector. That's all. And I will pass the value as hash GHAC because that's ID value. Okay. Something like, headphones. I'll comment this for now. Save this and run the program. Again, it launched Google Chrome, navigated through ebay.com, and entered the value as headphones. As I did not click on the search, it's not taking. If you want, again, you can click on the search, inspect, copy the value, that is GH button, this one, and you can paste it over here and choose click method because you're clicking on the search box. So that's how you can use CSS selectors as well. Next will be your partial link text. So if, some situations we may have to find the links by a portion of the text, and that it contains, because proper text will not be there. In such cases, we can use partial link text to locate the elements. And now talking about my favorite locator, XPath. It is designed to allow the navigation of XML elements with the purpose of selecting individual elements, attributes, or some part of an XML document for specific processing. So syntax goes like this. It has // a tag name at select attribute, an attribute name followed by an attribute value. I'll show you a simple example of using XPath. Let's take Myntra and try to locate this login information. As you can see here, it has an input tag and it has a placeholder whose value is your email address. So I'll write it over here only. As I have told, it starts with // I'll give it, and it has an input tag. Okay. And it also has a placeholder whose value is your email address. So I will place the value, and your value should be within single quotes. On writing this, you can see it was able to locate the particular element. So now say I want to write it using XPath. I'll copy this XPath and write it over here. And I'll send keys like some email address. So just run the program and check the output. It launched Google Chrome, that is your Chrome driver launched Google Chrome, navigating through Myntra, and it will write the prescribed email address. Okay. So this is how you can use XPath to locate a particular element on the web page. Sounds much easier? So this is how basically you can use different types of elements to locate a particular element on the web page. And you can use implicit and explicit waits. Yeah, when I talk about explicit waits, I'll show you how to use it. Now I want to use yahoo.com and I'll explain you explicit waits. Okay. So I have given the XPath for login username. I'll show you how. You can even use for this also, no issues. But I want to make you comfortable with different websites, so I'm just showing that. So when you click here, I inspect on this and I will write the XPath. I can give the XPath for this because it contains an ID whose value is login username. So same thing I have given over here. That is ID, that will be your username, and send keys as edureka@yahoo.com. And it has a click button, that is this next button. Again, it has an ID attribute whose value is login sign in. So based on that, I have written these two statements and I have used a WebDriver wait. Explicit wait is always achieved using WebDriver waits. Okay. It's a concept of the dynamic wait which waits dynamically for specific conditions. It can be implemented by WebDriver wait class. It doesn't have any keyword like explicit wait as it has for implicit. We can simply give WebDriver wait. So here I am creating an object of wait and I'm sending my driver, that will be this, and I'm giving explicit wait as 20 seconds. And then I'm creating a web element and asking it to wait until expected conditions is visibility of the element located by XPath, that is login username, that will be your email box. So it will wait until the expected conditions is visibility of the element that is located by this XPath. Simple. So save this and you can run the program and check the output. So there are many visibility conditions, like you have element to be clickable, element to be visible, URL to be located, and many more as such. You can simply give Control and Shift, you'll get to know. Let's see how the output will be. So it entered edureka@yahoo.com asking to move to next. Correct? So as it is a explicit wait, we can change the timings accordingly. But implicit wait one set cannot be changed as it is a global wait and it can be applicable to the entire program. But for WebDriver wait, that is your explicit wait, you have to keep on creating a WebDriver wait for specific elements. So it goes like that. Simple. So these are some of the best practices for locators. That is, they are simple and small as possible, and they work even after you change the properties of UI element. And they work even after you change the properties of UI element around the element you target. Sounds much easier, right? So if you want to learn more about locators, waits, and XPath, and more about the Selenium basics, you can check out the playlist for Selenium videos and you can find and master all these things. So that's all for the session on software testing tutorial. I hope you got a clear idea about manual testing and automation testing as well, and I hope you learned something out of it. Thank you and have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!